falling bodies, which we call as free fall, freely falling bodies, which means exactly what I told you. It is falling under the action of gravity with an acceleration of minus 10 meter per second square, or minus g. Okay, 10 was just an example. Now, Galileo also found out a very interesting pattern when the bodies fall down. First discovery was what? He said heavier body and a smaller body falls at the same rate to the ground. That is fixed. Everyone knows that now. He did not stop there. He went to one more very important conclusion, which normal people do not know, but students of physics should know. He came up with an interesting pattern observation, and today we call it as Galileo's law of odd numbers. This is a very strange way to call it. Law of odd numbers. Okay, not a perfectly valid term like Galileo's law of odd numbers. People may not understand, but this is what it can loosely translate into: Galileo's law of odd numbers. I'm sorry if I'm writing slightly cross like this, it is because of the position I'm sitting. Anyway, I'll try to correct it. Galileo's laws of odd numbers. What does that mean? Observe carefully. Let us say the body is falling down from a certain height to the ground. Okay, I'll take a big distance here. This is the ground, earth, and let us say the body is falling down from here. Let us take a time interval. I'll call it as tau. Okay, tau. This is the symbol, and time is read as tau. Okay, this is a Greek symbol. I could have taken t. I'll simply take another symbol called tau. Okay. So let us say time is tau, tau instants of time. So for this interval of time, how much the body would have moved? Suppose if tau is 1 second, okay, just an example. If it is 1 second, how much the body would have moved? You know the equation of motion, S equals ut plus half at square or minus half at square. This is also minus because it is displacement is downwards. This is also minus, and initial velocity is 0. So can I say, okay, I'll write it here, don't get confused, I'll write here. S equals ut plus half at square. So in an interval tau, how much it is falling down? S is negative because it is going down. So some negative value, and this acceleration is also negative, so they get cancelled with each other. It starts with 0, and half g tau square. That's the distance traveled in the first interval. Yes or no? Correct? Yes. So let us say in an interval tau, it travels a certain distance, and that distance is half g tau square. Suppose if it is 1 second, then half into g into 1 square. That's the distance it travels. Okay. Okay. Now from here, if I take double this time, suppose in my example, if this is 1 second, if it travels this much, in 2 seconds it travels how much? So what should I do from here? I have to apply the equation. Half, again velocity is same initially, 0 velocity, so that I'll not change. Half g into 2 tau square. Yes or no? Half g into 2 tau square. Do you all agree? In the example, if it is 1 second, if it travels this much, in 2 seconds, how much it travels? It would travel somewhat here, no? Correct? In 2 seconds. So in 2 seconds, how much does it travel? And it travels half g 2 tau square, and that much will be how much from here to here? That distance would be 2 square is 4, so that I'll bring outside. Rest everything remains the same, half g tau square. Correct? So here, if it is x distance, then this much is 4x. Do you agree? Correct? All of you, yes or no? If this is x, this much is 4x. Now what about 3 tau? In this much time interval, how much it travels? Again, I'll apply this equation. half g into 3 tau square, which will be 9 into half g tau square, correct? So this distance will be how much now? 9 half g tau square. Do you agree? Suppose if in the first second, if it travels x distance, then at the end of second it would have traveled 4 times the distance what it traveled here, correct? Then in the third second, the total distance traveled is 9 times what it covered in the first second. First tell me if you have understood till here, correct? Yes, in the first second, if it had traveled a distance x, then in the second from here to here, it would have traveled a distance of 4x. Then at the end of 3 seconds, it would have traveled a distance of 9x. Are you understanding? So what will be the next number? What will be the next number? 4 times tau square, 16 half g tau square. Do you all agree with me? Correct? So let us take the example of 1 second. Okay, in 1 second it travels some distance x. Then at the end of 2 seconds, it would have traveled a distance of 4x. At the end of 3 seconds, it would have traveled a distance of 9x. At the end of 4 seconds, it would have traveled a distance of 16x. Do you agree with me here? So what is the next number you can guess? What would that be? 25. 25 half g tau square. Yes or no? Yes. Now, observe carefully here, understand carefully. I hope you understood how I got this, correct? No confusion in that, no? Okay. Now let me see, I'll draw it very carefully now. See, it starts from here, and from here to here, if it covers a distance x, and this is in an interval t or tau or whatever it is, in 2 seconds, it would have reached somewhere here, and the total distance would be 4x. Do you agree? Then it would have reached somewhere here. Let me slightly put it like this. Here, and then here, and then here. This is quite okay. Okay. Why I'm drawing this? Because this is exactly how tap water falls. Okay. That's the problem. That is where we are heading to, if you are thinking where I'm going with this. Okay. If this object travels a distance x in time t, then in time 2t, this object would have reached from here to here. And how much would that distance be? 4x. In 3 times, if this is 1 second, the body reaches here. At 2 seconds, it will be here. At 3 seconds, it would be here. And how much would that distance be? 9x. Correct? How much would this distance be at the end of 4 seconds? 16x. Are you following what I'm trying to do here? Okay. Now, what is the distance it travels in the first second x? What is the distance it travels in the second second? Do you understand the meaning? How much is that? 4x minus x. That will be 3x. Do you agree? What is the distance it travels in the third second? See, in the first second, it travels this much. In the second second, it travels this much. In the third interval, it travels this much. In the fourth interval, it travels this much. Yes or no? Yes. So, in the first second, it travels x. In the second second, it travels 3x. In the third second, it travels how much? How much is this? How much is this? 5x. Yes or no? 9x minus 4x. Am I right? And how much is this now? 16x minus 9x. How much is that? 7x. And this pattern goes on, and Galileo found out this. What he understood is every second the distance traveled lies in the ratio of odd numbers. So in the first second, if it travels x, in the second second it will travel 3x, in the third second it will travel 5x, in the fourth second it will travel 7x, in the next second it will travel 9x, and this goes on till it reaches the ground. Is that clear? What is this called as? Galileo's law of odd numbers. Understood now?